All right, satellite travels at constant speed around a circular orbit. At this speed, it takes the satellite 50,000 seconds to go halfway around the circle. What are the x and y components of its velocity at point A, and at point B, and at point C? All right, so we should see its velocity at any given point is tangential, yes? Okay, so at A, the velocity, the x component should be negative 500 meters per second, and then the y component should be 0. At B, the y component should be negative 500, the x component should be 0. And at C, the y component should be 0, and the x component should be 500. Now, it's also okay if you did positive for A, but negative for C. But the issue is A and C have to be opposite. Yes, does that make sense to everyone? Okay. So whatever, we'll just say negative 500 meters per second, that's Vx. Then Vy is negative 500 meters per second, and then Vx is 500 meters per second. Then find Ax, Ay, and the x and y components of its average acceleration as it goes from point A to point C. Okay, so would we just use? So if we sort of do this the straightforward way, we know that the total time, the period to go around is, okay, that looks like a 6, is 50,000 seconds, right? So the time it takes to go from, what was that, from A to C, the time it takes to go from A to C would be 25,000 seconds.
It's already 50,000 for the diameter.
Oh, was it? Was it for halfway around? Yeah. Oh, okay. Sorry, I misread that. To go halfway around, you're right, thank you. So that's easy. We were told that, so that's just the period time from A to C. Erase this. Okay, very good. All right, so then we know they want us to find AX and AY. So AX is going to be Vx at C minus Vx at A over TA sub C, and then AY is going to be Vy at C minus Vy at A over TA sub C. And then Vx of C was 500 minus Vx at A was negative 500, so that gives us 1,000 meters per second over 50,000 seconds. So knock that off, and 1/50th is like 0.02, I think. Is that right? Yeah. 0.02 meters per second squared. And then for the other one, Vy of C should be 0. Vy of A should be 0, so that should give us 0. Because there's no change. Vy is the same. Okay, then for C, now find x and y components of its average acceleration as it goes from point B to point D. So point B to D, if we go from, so if we say AX of, well, how did I say it here? Yeah, I guess I'll just say AX. AX and AY. So the idea should be similar, right? Because from B to D, B is negative 500, D is positive 500, so we're going to get to 1,000. So then our Y this time is going to be, is going to be 0.02 meters per second squared, and then our X is going to be 0. Does that make sense to everybody? Because we have nothing in the X. Okay? And then for D, are the components of the acceleration the same in B as they are in C? If we're talking about the tangential acceleration, then the acceleration it's zero all the way around because it goes at a constant velocity. If we're talking about the acceleration in the radial direction, then are the components of the acceleration the same? No. Right? So the components of the acceleration let me see. Because which points? B and C. So this was A, this was B, this was C, and this is D. So at this point, the acceleration's like that, and at this point, the acceleration's like that. So if you look at the two components, they should be different. Yes, no? Questions? So that one, I mean, you just calculated the components in in part B and C, and showed that the components were different for the different things, so that one's pretty obvious. Any questions? Yes? Oh, that's just the time to get around. To be more accurate, I should have called it capital T. That should have been lowercase, because usually capital T stands for the overall period, which would have been 100,000. Anyone else? Okay.